So, there are four major sections on SAT Math. First is Heart of Algebra. Then you have Geometry. You have Advanced Math. And the fourth one is Problem Solving and Data Analysis. Okay. So in today's session, the word problems that I will be taking, those word problems will be from Heart of Algebra. Okay. Because these word problems just involve the knowledge of Algebra 1. For the other word problems, which are part of Geometry, Advanced Math, and Problem Solving, you need a altogether different knowledge base. Like for problem solving, you need to know the concepts of statistics, the observational studies and inferences and all of that stuff. For advanced math, you need to know about exponential functions. Geometries, again, hold together a different subject. So I will be taking the word problems of Heart of Algebra today. Okay. Now, story time. When I was a high schooler, when I was in high school, I used to be afraid of word problems until I learned this one simple trick. This is one simple trick that I learned one fine day. And after this trick, the word problems were not that scary for me. And this trick is called translating English to math. That's the only thing that you need to master in order to get over the fear of word problems. Okay. Why do we fear word problems? What's that thing that scares us about word problems? The only thing is that word problems are long. They are given in the form of a paragraph. And the moment we see a big paragraph, we just panic. Okay. Big paragraphs, long paragraphs, they just make us panic. Okay. And the word problem itself is not difficult, okay, but just the language, just the plethora of words is what makes us panic. Okay. So in order to not panic, you need to translate whatever is written in English into math. Okay, that's the only thing that you need to master. That's what we will do in today's session. Every word problem we will do it using this simple trick. Okay, let's get started. This is type 1. Which equation or expression represents this situation? Okay, so you see there are 3 word problems, and these 3 word problems are based on this type. First thing that you have to do whenever you see a word problem is you will read the last sentence first. Do not read the word problem from the beginning. Read the last sentence first. So the last sentence is, which equation represents this situation? Here the last sentence is, determine how many fewer average miles M he should drive each week. Here the last sentence is, which equation represents this situation? And actually this works for every type of question. On SAT Math especially, just read the last sentence first, and keeping that last sentence in mind, then start the word problem from the beginning. Now, so I will be taking one problem from each type, okay? So there are 3 word problems you can see on the screen. I will be discussing one problem, okay? And the rest of the 2 problems you will have to do as part of your assignment. So I will be sharing this document with you after the session, and that will be your homework or assignment, that the rest of the 2 problems you'll have to do on your own for every type. Okay, so we read the first sentence first, which equation represents this situation. So we have 4 answer choices, and we have to figure out that which of these answer choices represents this entire situation. Now we read this situation, what is going on? So it says, a manufacturing plant makes 10-inch, 9-inch, and 7-inch frying pans. Okay. Right now you cannot translate. Remember the rule? You have to translate English to math. So it says, during a certain day, the number of 10-inch frying pans that the manufacturing plant makes is 4 times the number N of 9-inch frying pans it makes, and the number of 7-inch frying pans it makes is 10. During this day, the manufacturing plant makes 100 frying pans total. Now you see, this is a lot of information, and this is such a big paragraph, and the big paragraphs will always make you panic. But actually, the information that you need, the only information that you need is in this part of the problem, and this part, and this part. Okay, so now we will use this rule. We will translate English to math. So there are frying pans, 10-inch pan, 9-inch pan, and a 7-inch pan. So 10-inch, 9-inch, and 7-inch. Okay, and you have to see that this variable n is for what? It says number n of 9-inch frying pans it makes. This number n they are using for the 9-inch frying pans. So how many 9-inch frying pans they are making? N. Okay, there are n number of 9-inch frying pans. So 9-inch frying pans are n. How many 9-inch frying pans are there? N. Then it says the plant makes, so the number of 10-inch frying pans that the plant makes is 4 times the number n of 9-inch frying pans. So the number of 10-inch frying pans is 4 times. So how do you translate 4 times? Whenever we see times, that means multiply. So 4 times the number n. So the number n. That's it. That's how you translate. So this is what? This is the number of 10-inch frying pans. 10-inch frying pans. 4n. So here we will just write 4n. And it says the number of 7-inch frying pans it makes is 10. So 7-inch frying pans is 10. So that's it. Here you write 10. And that's it. Now you have converted this entire word problem from English to math. Now, this is the only information that you need. And finally, it says that the total number of pans it makes is 100 frying pans total. Okay. So this plus this plus this, it totals 200. That's it. 4n plus n plus 10 is equal to 100. And here you don't have to do anything about this 10, 9, or 7. This is just the name of the pan, like the 10-inch pan, the 9-inch pan, the 7-inch pan. You don't have to do anything about these numbers. So your final equation will be 4n plus n, that is 5n. 5n plus 10 is equal to 100. So that means answer choice D is correct. Now look at answer choice A. This is what we call a trap answer. Because here they've also multiplied these numbers by 10, 9, and 7. You might think that this 10, 9, and 7 will be multiplied by the number of pans. But no, these numbers have nothing to do with the number of pans. Okay, this is just like the name of the pan, like a type of, these are the types of pans. Okay. Okay, now the rest of the two problems, problem number 2 and problem number 3, are also similar to the first problem that we did. So those two problems will be your homework. Okay, just read the problem, convert it from English to math, and just apply the operations. Let's move to type number 2. Type number 2 is based on linear functions. Okay. So let's just quickly review what were linear functions. Linear functions are of this form. F of x is equal to mx plus b, where m is the slope, okay, and b is the y-intercept. So in these word problems, you have to write the equation of the linear function, and you'll see that the final function will be of this form, mx plus b. You can see in the answer choices, all the answer choices are of the form of linear function. F of x equals to mx plus b. All the answer choices, okay? Okay, so this time let's pick up this problem number 2. Problem 1, problem 2, they are similar. Problem 3 is slightly different. Let's do problem number 2. Problem number 2 says the cost of renting a backhoe for up to 10 days is $270 for the first day and $135 for each additional day. Which of the following equations gives the cost y in dollars of renting the backhoe for x days where x is a positive integer and x is less than or equal to 10? Again, remember, first you have to read the last sentence, okay? Last sentence says, which of the following equations gives the cost y? So we have to find out the cost y, okay, of renting the backhoe for x number of days. Okay, so now you know that you have to find out the cost. Keeping that thought in mind, now read the first sentence. The first sentence says, the cost of renting a backhoe for up to 10 days is $270, okay? And for the first day. So for the first day, If you're renting it for the first day, what will be the cost? $270. Okay, $270. So we are going to write this. And then $135 for each additional day. Which of the following equations gives the cost y for renting the backhoe for X number of days? So let's suppose you are renting it for X days. That's given in the problem. We are renting it for X days, X number of days. Okay. Now for the first day, the cost of renting is $270. Day one. Okay, $270 for the first day. And $135 for each additional day. So if you have rented it for one day, then how many days are left? Out of X, when you have rented it for one day, then how many days are left? X minus 1 days are left. This is the remaining number of days. For the first day, you have already paid $270. Okay. So how many days are remaining? X minus 1. So think of it like this. Let's say that you rented the backhoe for 8 days. Then for the first day, you have to pay $270. And then for the remaining number of days will be 8 minus 1, 7. For the 7 days, you'll have to pay $135 for each additional day. So $135 for each additional day. So you multiply it by 7 because you are renting it for 7 additional days. Okay. So for X minus 1 days, the cost will be $135 times X minus 1. That's it. So for day one, the cost is 270. And for the remaining days, the cost is 135 times X minus 1. That's it. Now you just have to simplify this expression. Once you simplify this expression, you'll get one of these 4 answer choices. Problem number 1 is also similar. And problem number 3 is slightly different. So problem number 1 will be your homework. Try problem number 1 and problem number 3. And for type 1, problem 2 will be your homework and problem 3 will be your homework. Okay, let's move ahead. Type 3. Type 3 is based on interpretation of M and B. So in type 2, we just had to write the equation in this form. F of x equals to mx plus b. We did not have to do anything, like we did not have to deal with M and B. In type 3, we'll have to interpret M and B. First of all, let's understand what is the meaning of the slope and the y-intercept in the context of word problems, in the real world context. Can anyone tell me the meaning of slope in the real world context?
The slope is the rate of change.
The rate of change, that's absolutely correct. Do you have anything else? Like in the real world context?
Oh, like speed compared to the distance.
Okay. Can you relate it with like what happens to the y value as we change the x values?
For every one change in x, there is the slope change in y.
Yes, every 1 unit change in x. When we change the x values by 1 unit, whatever change is happening in the y values, that is given by the slope. So slope tells us the change in the y values with every 1 unit change in the x values. Perfect. Now, one thing is that you will definitely get one problem based on type 3. One word problem will be definitely there on your SAT math. Okay, so as Igor said, the slope tells us the change in the y values for every, this is super important, for every 1 unit change in the x values. And this is actually This is actually visible from the formula of slope as well. You know, the formula of slope is what? Y2 minus y1 over x2 minus x1. We all know this is the formula. We also know that this is the rate of change. Okay. But knowing this much is not enough to do the word problems which are based on this concept. Okay. You need to know the exact meaning of slope. The exact meaning of slope is this. As we increase the x values by 1 unit, actually increase or decrease, what is the change that happens to the y values? Okay, that value is given by the slope. So, first of all, you have to identify that the given word problem is based on this concept. Okay, you need to identify that the given word problem is based on the interpretation of M and B. How will you identify that? See, most of the word problem, they'll say this statement: which of the following describes the meaning of 2 in this context? You look at the equation. This equation looks like a linear function, right? Because it is in the form of mx plus b. So this is linear function. Okay, and they're asking for the meaning of 2 in this context. What is 2? This is 2. Right? So 2 is nothing but the slope here. See, the only difference is that instead of y and x, they have used the variable L and W. You can also write this equation like this: y equals to 2x plus 30, if you're more comfortable with x and y. Okay, like I am more comfortable with x and y. So I always write the equation in this standard form. Okay, so you need to realize that this 2 is nothing but the slope. And we have to tell the meaning of slope. That's it. So first thing is that you will identify the type of the word problem. So this word problem is based on type 3, which is interpretation of slope and y-intercept. After that, you will read the last sentence, that which of the following describes the meaning of 2 in this context. Now we know that they are talking about the slope. 2 is the slope. Then you recall the meaning of slope. So the slope was change in the y values for every 1 unit change in the x values. Then you identify what are your x values and y values. So here, the y values represents length, because I've taken y instead of L. Okay, and L is the length L of a spring. Okay, length of spring. And the x values are, like for this context of this word problem, the x value, that means the W is the weight of the object. Okay. Okay. Now, what does 2 represent here? So your 2 is change in the y values. Read the definition. Change in the y values. What are the y values? Length of spring. So change in the length of spring for every 1 unit change in the x values. That means for every 1 Newton increase in the weight of the object. See how I'm relating this definition to this word problem? So as we increase the weight of this object by 1 Newton, okay, the length of the spring will increase by 2. Keep increasing the weight of the object by 1 Newton, then the length of the spring will increase by 2 units. Okay, so for every 1 Newton increase in the weight of the object, that's the meaning of 2. So first you write your own definition and then you look at the answer choices. Okay. So the first answer choice is the length in centimeter of the spring with no weight attached. No, that doesn't make sense. B, the weight in newtons of an object that will stretch the spring 30 centimeters. No. The increase in the weight in newtons of the object for each 1 centimeter increase in the, no. The last answer says the increase in the length in centimeters of the spring for each 1 Newton increase in the weight of the object. Yes, that's what we wrote as well. Change in the length of spring for every 1 Newton increase in the weight. Yes. So 2, which was the slope, that tells us the increase in the length of the spring when we increase the weight of the object by 1 Newton. So answer choice D will be correct. Now, your second word problem is also similar to the third word problem. This will be your homework. And first word problem is slightly different, but it is based on interpretation of slope. Okay. In the second word problem, you have to tell the meaning of 6. And 6 here, in this case, 6 will be the y-intercept. Okay, we did not discuss the y-intercept. Y-intercept, the meaning of y-intercept is this number, b, the y-intercept. This tells us the value of y when x was 0. Or we say the initial value of y, or the beginning value of y, like when we were just starting. Okay, so this b gives us the value of y, or the value of the function, when x was 0. Okay, that's why it is also called the y-intercept. Y-intercept, because the y-intercept means the point at which the line is crossing the y-axis, and at that point the x-intercept is always 0. I mean, the x coordinate is always 0. So this is of the form 0 comma b. X coordinate will be always 0. Okay, so that's your y-intercept. Okay, so problem 1 and problem 2 will be your homework. Let's move on to type 4. Type 4 is system of linear equations in 2 variables. Here I've taken 4 problems. And this, I would say that this is the easiest type. Okay, let's try problem number 3. So it says a movie theater sells 2 types of tickets. Now, how will you identify that a word problem is based on type 4? Or like a word problem is based on system of linear equations in 2 variables? You will see that they will talk about 2 things. Like see, in this one, they're talking about 2 types of tickets. In the second word problem, they're talking about Morgan ran and biked. Again, they're talking about 2 things. Morgan is running and biking. Okay, then in problem number 4, they're talking about raspberries and blackberries. Okay, then in problem number 1, they're talking about in the month of August and in the month of September. So they're talking about sales of car in the month of August and September. So if you see that there are 2 things and you have been given the data for 2 things, okay, so you will see that you'll be able to make 2 equations. So we'll do problem number 3. Okay, let's do the problem number 3. First, read the last sentence. Okay, always read the last sentence first. Last sentence says, the purpose of reading the last sentence is that you first keep in mind that what do you have to find out. Okay, so here, don't read from here, read it from this part, okay, after the comma. How much in dollars was spent on adult tickets? So this is what we have to find out. Now, keep this in mind that I have to find out how much was spent on adult tickets. Keeping this in mind, we will read the problem from the beginning. It says a movie theater sells 2 types of tickets. 2 types of tickets, adult tickets for $12 and child tickets for $8. Okay, so I feel better when I write the given information visually. Okay, so I'm writing adult tickets. I'll just use letter A for adult tickets. This is for $12. And I'll use letter C for child tickets. This is for $8. Okay. So let's just say that the number of adult tickets which were sold, let's just use letter A to denote the number of adult tickets, and let's use the letter C to denote the number of child tickets. Okay, then it says if the theater sold 30 tickets for a total of $300, and then rest, we have to find out how much was spent on adult tickets. Okay, so you know that this is based on system of linear equations in 2 variables. So we'll get one equation for adult tickets, you'll get one equation for adult tickets, and we'll get one equation for child tickets. Okay, so they earned total of $300 from the sale of both types of tickets. Okay, so how much they earned from the sales of adult tickets? Well, one ticket is for $12, so then A number of tickets will be 12 times A. Okay, so this is the expression for the sales of adult tickets. Okay, 12A. And then for the child tickets, one ticket costs $8, so C number of tickets will cost 8 times C dollars. Okay, so what will be the total sales? Obviously, you have to add both of these terms, right? So this will give you the total sales. So 12A plus 8C, this is the total sales, and the total sales is also equal to 300. So put it equal to 300. That is your first equation. Let's erase this. And now you also need another equation. So we have not used this information so far. It says that the theater sold 30 tickets. That means the total number of tickets that they sold was 30. So the number of adult tickets plus the child tickets should be equal to 30. So A plus C should be equal to 30. That's it. These are your two equations. Okay. And now in this problem, if you just find out the value of A and you select that answer choice, that, okay, how much was spent on adult tickets, and you find out the value of A, that will be wrong. Okay, first of all, let's find out the values of A and C. Now here, I would say that you have to solve this system of equations on DESMOS. Okay, I'll cover DESMOS later in the third session, but today as well, if any problem can be solved on DESMOS, so we will solve it on DESMOS. Okay, so our equations are 12A plus 8C equals to 300. So what we'll do, instead of A and C, we'll use the variable X and Y. Okay, and I'm going to type on DESMOS 12x plus 8y equals to 300. 12x plus 8y equals to 300. Okay. So here we have the line, the graph for the first equation. And the second equation, I'll type x plus y equals to 30. It doesn't matter if you change the variables. DESMOS will not understand A and C. DESMOS only understands x and y. So we'll say x plus y equals to 30. Okay, and now you all know that the solution to the system will be the point of intersection. Okay, wow, lovely. So the point of intersection is 15, 15. So that's the solution. So A is 15 and C is 15. Okay, X and Y were 15. So both A and C are 15. Okay, so that means the number of adult tickets sold is also 15 and number of child tickets sold is also 15. Now, if you write your answer as 15, that will be wrong. Read the question again. It says, how much in dollars was spent on adult tickets? Okay, so we have to tell the amount which is spent on adult tickets, and that amount is 12 times A. 12 times A. So you have to do 12 times 15. So this will be the final answer. Okay, so then problem number 1 and problem number 2, problem number 4 will be your homework. Let's move to type 5. Type 5 is about linear inequalities in 1 or 2 variables. Okay. 1 second. Okay, so now, first of all, how will you identify that a word problem is based on linear inequalities? Now, whenever you have a problem, word problem based on linear inequalities, first thing is that you should look at the answer choices. Obviously, you will see the less than and greater than signs. Okay, that's a good indication to tell that this problem is based on linear inequalities. Other indication is that you will see words like at least, you will see words like at most, you will see phrases like not more than, you will see something like not less than. These types of phrases you will see in the word problems. Okay. Okay, let's do problem number 3. Again, first read the last sentence first. It says, which inequality represents this situation where X is the price in dollars of a ticket sold during this event? So we have a situation in this word problem and we have to write an inequality for this given situation. Okay. Now, keeping that in mind, we will read the problem from the beginning. It says, a team hosting an event to raise blah, blah, blah. Once you become fluent, you will be able to skip the irrelevant information. Now, this, I would say that it is irrelevant, this part of the problem. Okay. And naturally, your eyes will just go to the numbers in the problem. So this is a number. this is a number, and the words that are written before and after a word. So immediately look at the number and read what is written before the word. At least 140 tickets before this event and at least 220 tickets during this event. This is the only relevant information that you need. Okay, then the next number is this. Read what is before. A total of at least $5,820 from all tickets sold. Then the next number is this. So it says the price of a ticket during this event is $3 less than the price of a ticket before this event. Okay, so there is some event going on. We don't care what is the event about. Okay, so they are talking about, again, two types of tickets. First type is a ticket which is sold before the event. And the another type of ticket is ticket which is sold during the event. Okay, and in order to meet their goals of sales, they have to sell at least 140 tickets before the event. So before the event, they have to sell at least 140 tickets. Okay, and during the event, they have to sell at least 220 tickets. Okay, that's the information that's given in the first sentence and the first sentence. And then it also says to raise a total of at least $5,820 from all tickets sold. So the number of tickets sold before the event plus number of tickets sold during the event. And if you add the sales from these two types of tickets, the total sale should be at least. Now, what will be the sign that you will use for at least? At least means this sale that you're doing, it should be either equal to this number or it should be greater than this number. Either equal to this number or more than this number. Okay, so the sale should be either equal to or more. So this is the sign that we will use. It should be greater than or equal to $5,820. Okay, now we have to create the expression for sale. Okay, now in the answer choices we see we have X. Okay, so what is X? In this problem, X is the price in dollars of a ticket sold during this event. Okay, so X is the price of the ticket which was sold during the event. Okay, and then the price of a ticket during this event is $3 less than the price of a ticket before the event. Okay, so the price of the ticket during this event is $3 less. $3 less than price of a ticket before the event. So the price before the event should be X plus 3. Okay, because the price of during ticket is $3 less than the before ticket. Okay, now you can create the expression for sales. So it is going to be the sales from the before tickets will be 140 times X plus 3. And the sales from the during ticket will be 220 times X. This is the expression for sales, and this should be greater than or equal to 5,820. That's it. So look at the answer choices, and I think it should be B. 140 times X plus 3 plus 220. Just from this expression, you can eliminate A, because in A it is less than, and you can also eliminate C. Okay, all right. So problem number 1 and 2 will be your assignment. Let's move to the final type 6. And actually, this is quadratic functions is not from heart of algebra. It is actually part of advanced math. This comes under non-linear functions. Okay. Now, any word problem which is based on quadratic functions, any word problem, okay, it will be of this type, where the context will be like this, that you're throwing something, you're either throwing a ball or whatever, you're throwing something and it takes a maximum height. Obviously, whenever we throw something, the path of that object follows a parabola. So you throw something, it takes a maximum height. This is let's say that we are throwing a ball. It will reach a maximum height, a certain height. So this is the maximum height. Okay. And then after some time, it will touch the ground. Okay. So all of these word problems, which are based on quadratic functions, 95% of the times they will be based on this context. Okay. When you're throwing something. Okay. So in these type of word problems, you should know that the maximum height that the object is taking, it is represented by the vertex of the parabola. And your parabola will be a sad parabola or opening downwards parabola. Okay. So you obviously, you know, there are two types of parabola, opening upwards and opening downwards. So in these contexts, the parabola will be opening downwards. Okay. And you should know that the vertex of this parabola will be actually the maximum height. Okay. And usually the equation of, like in these contexts, the equation is like this. The height is like the height of the object is a function, it will be a function of time. Okay. Then you will see the equation of the parabola in the vertex form, which is given by a times, not x, but this time instead of x, we have t minus h whole square plus k. H comma k is the vertex, so maybe we can use another variable for height. Let's use the variable capital H. So here we have a parabola. Okay, this denotes the height of the object t seconds after it was thrown. For example, let's take problem number 1, and it will be always negative a. Negative a because in this context, the parabola is a downward opening parabola. Whenever you have a downward opening parabola, this a, like this, is negative. Okay, so it says a machine launches a softball from ground level. Okay, so the softball reaches a maximum height of 51.84 meters above the ground at 1.8 seconds and hits the ground at 3.6 seconds. Which equation represents this situation? Okay, this is the only type that you'll get from quadratic functions. Like if you get a word problem, this is the only type that you will get. Okay, so again, you read where you see the number. Here is a number. So 51.84 meters is the maximum height of the ball. Okay, the maximum height that the ball is taking. That is 51.84. And it is taking this height after 1.8 seconds. So this is time t after 1.8 seconds. So the x coordinate of the vertex is 1.8. The ball is taking the height of 51.84. So these are the coordinates of the vertex. The vertex is 1.8 comma 51.84. So let's write the equation of the parabola in the vertex form. So it is given by negative a times t minus the x coordinate of the vertex, which is 1.8 whole square, plus k. K is 51.84. Okay, let's look at the answer choices. We still haven't found the value of a. Okay, we haven't found the value of a, but let's look at the answer choices. If you look at the answer choices, the closest answer choice seems like D. T minus 1.8 whole square plus 51.84. Okay, it is not A, it is not B, and it is also not C. The answer choice that we have written is this. It will be answer choice D. Now, how do we find out the value of A? Like here you see negative 16. How do we find out the value of negative 16? Now, we haven't used this information. It says it hits the ground at 3.6 seconds. That means what? When it will hit the ground, hits the ground means that its height will become equal to 0 after 3.6 seconds. Okay, so basically the y value is 0. So 0 is equal to a times, put this point into the equation, 3.6 minus 1.8 whole square plus 51.84. And from here, you will get the value of a. Okay. And you'll get the value of a as negative 16. In the beginning, don't write negative a, just write a. When you will solve the equation, you'll get the value of a as negative 16.